given an infinite series A, where all the terms are positive, and the limit of the ratio of the next term in the series to the current term in the series, as n approaches infinity, is equal to rho, then the ratio test has three rules. So if rho is less than 1, the series converges. If rho is greater than 1, the series diverges. And if rho is equal to 1, then the test is inconclusive. So remember the geometric series, which you can write as follows after expanding a few terms. Then you can see that the ratio test verifies that the ratio of the geometric series is constant. And therefore, if this ratio is less than 1, the series converges, which is consistent with the convergence conditions that we derived for the geometric series. Let's use the ratio test to determine if this series converges. So we take the limit as n goes to infinity of the ratio of the next term in the series to the current term in the series. And doing a bit of algebra, we can write this as follows. And the second term is 1/2, so we can write the limit as follows. And therefore the limit evaluates to 1, so we obtain 1/2. And because this value is less than 1, then the series converges by the ratio test.